Okay, so today we're talking about more resistors. We will have to take some notes on this today, so please make sure you have a pencil and a piece of paper out. And once again, make sure you're stopping the video. Just pause it when I say what note to take or what diagram to draw. This will also be part of your lab as well. So make sure you're just pausing, getting caught up, and then moving on with the video. So first thing, make sure and write down more resistors is the title of these notes. First thing we're going to talk about is a potentiometer, and here's just a couple examples of what that thing might look like. Sometimes they've got this kind of round appearance right here, as many of these do, and sometimes they actually have a straight appearance like this one, just kind of a straight line appearance. So let's figure out what this thing is. Well, you've used these before. Potentiometer is a resistor that can change its resistance through motion, turning, sliding, etc. So go ahead and write that down right here, potentiometer, and what the definition is. And also make sure you get the symbol down here. Okay, so the symbol's right here. Now it looks just like a fixed resistor, except for we have this arrow underneath it. And that arrow is important because it signifies that you can use motion to change this thing. So we've got potentiometer, the definition, and the symbol written down. Now we've got this example picture over here of a piece of the inside of a car, and there's a couple potentiometers here. I want you to see, just by looking at the picture, take a pause real quick on the video and see if you can point out where one or two potentiometers might be. Okay, so we're back. The first one that many people get right away, is the volume button on the radio here. That volume button you can turn, and if you turn it one way, clockwise typically, you can decrease the resistance in the audio system, making the speakers louder. If you turn it counterclockwise, the other way, it'll turn the volume down by including more resistance. Okay, so less electricity gets through to those speakers. So kind of neat. There's a couple examples in here. We're going to keep moving on. So we want to finish this statement. The blank resistance, the brighter the light. Okay, so the blank resistance, the brighter the light. So more or less. If you said the less resistance, the brighter the light, you are correct. Less resistance means more electricity. Remember, they're opposites. Okay, so if you have more resistance, you're going to dim the light. If you have less, you're going to brighten the light. Let's keep moving. Second note we've got to take down is on a thermistor. Okay, so thermistor. Now, this is one that changes resistance with temperature, and that's really all you have to write down. Okay, it changes resistance with temperature. So the full definition is it's temperature-sensitive device where the resistance changes with the temperature of the thermistor, this thing right here. Some will lower resistance with higher temperatures, and some will raise resistance with higher temperatures. So they can be made in either way. Okay, some will lower, some will heighten, depending on the temperature. Make sure you get this symbol down as well. Okay, thermistors change resistance with temperature, and this is the symbol. Once again, it looks like a fixed resistor symbol, but this time there's kind of like it looks like a hockey stick going through it. Okay, and that symbol means or stands for temperature. Okay, moving on. The last of our variable resistors we're going to be talking about is a photoresistor. Okay, so make sure and get that written down. A photoresistor is a light-sensitive device in which the internal resistance changes with a change in light intensity. So, once again, some will lower with more light, some will raise with more light. We can chop this down to a resistor that changes resistance with light. A resistor that changes resistance with light. Here is our symbol for this resistor. Make sure and get that written down. Once again, a normal fixed resistor symbol, but this time we've got a circle around the outside. And these two arrows, which we are familiar with because we know that these indicate light. Now, notice that this time, instead of like the LED where they're pointing out of the symbol, this time they're pointing in. That means light affects this thing. It doesn't give off light, it affects what this thing will do. So that's why they're pointing in, is because it says it takes light to make this do something. Okay? So, what we're going to do now is we're going to take a look at a couple of pieces of paper here that we're going to need to use for our lab. Okay? We're going to make a couple of circuits. The first is a potentiometer circuit. So what I want you to do is write down a number 1, circle it, and write potentiometer next to it. And then we're going to draw this diagram. And this is a sloppily drawn resistor symbol, or potentiometer symbol. I apologize that it's sloppily drawn. Pardon Mr. Liticote's poor artistry. So go ahead, pause, jot this all down, and actually I want you to write down what's on the bottom as well. So pause, write that down quick. Okay, so what's going on here? Well, we've got a 6-volt battery, we've got a potentiometer right here, and we've got an LED down on the bottom here because we know that symbol. Let's take a look at what that looks like. So in our snap circuit kits, we've got our battery. We're going to hook up to the 6-volt side, and remember, we'll come back into a negative. We always go out of a positive or a number, and we come back into a negative. All right, here is the potentiometer. Okay, now be careful because there's other parts that look a lot like this, but this one, you'll notice you can slide this little black piece. It's a slider. It slides across. That's how we know we've got the right piece. All right, now what we've got to do, there's 3 hookups on here. You always have to have, and I'll try to move this so the light's better, you always have to have one of your wires connected to this one with the arrow here, and then you can connect your other wire to either side here. So here's how I'm going to do it. I'll connect straight over from my battery, like so. I'll connect to my LED, and finally I'll connect my LED back to my negative side of my battery. Now remember, your LED always needs to have that arrow on it pointing towards the negative. Okay, if not, it will not work. Let's see if this thing works. Okay, so we've got it plugged in. Let's try moving this dial. Okay, and as I slid it, I'll try to cover it up because the light's bright. As I slid it, it got more and more bright. Okay, so that slider will actually manipulate the resistance here. Okay, and as it says on the bottom of your sheet of paper, or on the bottom of the sheet of paper that I showed you, I want you to see what else works besides the LED. Okay, so see if maybe, I don't know, something like a buzzer you can swap out, or a light bulb. Okay, try some other things, the motor, see what else works with that potentiometer here. Okay, second thing that I'm going to have you do is a photoresistor lab. Okay, now the photoresistor is, once again, pretty much the same thing. We're just swapping out that potentiometer for photoresistor. So go ahead, write down everything on this page. Sorry about that. Go ahead and pause and do that now. Okay, so once again, we've got a 6-volt battery, we've got a photoresistor, and an LED. Okay, now this one's going to be a little bit different, so pay attention here. I'm going to hook up this circuit, just like it shows. And our photoresistor is one of the clear pieces. It looks like this, very similar to a light socket, but you'll notice this big black ring in here. Okay, so I'm going to hook this in just like that. And let's get our other connections made. Just like that. And if I plug it in, nothing's going to happen. So what this thing needs is it needs light to be shined into this little cavity here. Now, here's how we do that. You're going to take a couple of these wires that are located in your kits, and you're going to plug them in, one right above this connection, and one right above this connection. Now, the ends of them you're going to plug in to either side of a light bulb. Okay? And you don't have to have this thing hooked to the board. Alright? So we're going to plug these in just like so that lights up. And then when you take it over your photoresistor, you should get that LED to light up when the light is in front of it. Okay? Now I want you to see what else, once again, this works with. See if you can swap out this LED for something like a buzzer or a motor, etc. Okay? Last but not least, if you get done with all of that and you're looking for something to do, I want you to go above and beyond. I want you to take a peek at this motion detector. I'm not going to tell you how it works. What I want you to do is figure out if you can get it to work on your own. Once again, there's 3 inputs here, so you have to figure out, okay, which 2 of the 3, if I hook up to them, will make something like an LED or a buzzer or a motor work. So go ahead, take your notes, go into the lab if your partner is done, and go ahead and start this lab.